Everyone. Good morning. I wonder how much of this there is on Mars. I wonder how much there is on the moon. You know, now that I've tried it, I don't think I could live without it. Good morning, you guys. I'm Bill Nye. I'm Vice President of Planetary Society, the largest non-governmental space organization in the world. And this morning we're going to talk about the moon and Mars and how we're all going to go there and change the world for us. So joining us, welcome, and joining us this morning is, you know, you hear people say this, the world's foremost authority. Well, we kind of have four of the world's foremost authorities here this morning. It's very exciting. We'll start with Rick Gilbrech, who's the Associate Administrator for Exploration. Now, is it the Exploration Directorate?
Exploration Mission Systems Directorate.
The Exploration Mission Systems Directorate. Because it allows us to add some more letters. That's good, yeah. And then we have Jun Kawaguchi.
Yes.
And you're the Director of Moon and Planetary Exploration for JAXA, right?
Yes.
So at JAXA, the moon and planetary exploration are combined.
Combined.
Yeah. Is it that way at NASA, Rick? Kinda? Yeah, kinda. Yeah. And then we have Sergei Krikalev, who's the Vice President of Energia right now, right? And unlike many of us, Sergei, you've flown in space.
Yep.
And it was fun.
It is.
And then finally we have Bruno Gardini, and you are the Director of Human Spaceflight.
Not quite. I am replacing Simona Di Pippo. She is the Director of Human Spaceflight. So
What are you the Director of?
Exploration Program Manager.
The Exploration Program Manager for ESA,
Yeah.
European Space Agency. This is fantastic. This is great. Now, what we'd like to do this morning is, I know how much you all enjoy listening to prepared statements. I know that's among your favorite things. Of course, I'm right there with you, but you'll have to enjoy the prepared statements online, which is what we do now, you know, just watching. Instead, we're going to try to have a conversation, and we very, very much want to get your questions. So if you are here and you don't have any questions about Moon and Mars, well, you might ask yourself why you're here. That's all I'm saying. So we want to have a conversation. What I'd like to do is start with the following anecdote. Before we had this session, I got many, many emails about the session, the importance of showing up on time, and the dress code was kind of implied. You know, I noticed the head guy, Jim Zimmerman's always wearing a suit, so I thought I'd wear a suit. And my policy, when I wear a suit, I also wear a shirt. I just think if you don't have a shirt on, it's distracting. But I went that way. And then it's the email from a guy who was referring to yesterday's plenary, which was about robotic exploration only. He said, well, a couple of your questions, Bill, are redundant. We will resolve all those questions the day before. All the robotic versus manned or human exploration. We'll take care of that the day before. So you might want to cross out a couple of your prepared questions. Oh, yeah, thanks, because that's all taken care of. Anyway, Rick, I'd like to start with you. We were talking beforehand in the back, and you brought up the point that you have to deal all the time with people who wonder, why are we planning, or why are many of us planning to go back to the moon en route to Mars with humans? All right, so take it.
All right. Well, we get that question a lot. It's a very fair question. People see the Apollo program, the lunar landings. They wonder, don't we know all we have to know about the moon? We see all these great pictures from Spirit and Opportunity from Mars, and Mars is more intriguing, so why aren't we going straight to Mars? Well,
why aren't we?
Well, there's a good reason. Because we do have a moon 3 days away from home, and because we're building capabilities that far exceed what the Apollo program did. Now, the Apollo program was wonderful. It's why I'm here today. That's what got me hooked into the moon. But we are taking 3 times the mass to the lunar surface. We're taking 4 people down to the surface instead of 2 like they did in Apollo. And we're going to stay initially for 7 days as opposed to the 3-day sorties. And that will build up capability where we can eventually have a 6-month stay on the lunar surface. And that will really allow us to iron out a lot of the systems that we'll need to do the eventual missions to Mars.
How long do you anticipate a mission to Mars? How long would they stay on the Martian surface?
Well, there's several ways you can go to Mars. You can go in different ways where you have transit times that vary and lunar or the Martian stay times. The ones we're looking at currently, you have a 6-month journey there, which is very similar to a 6-month stay on International Space Station, and then you have 18 months on the surface before the planets align, and then you have a 6-month journey home, so 30 months.
Does everybody agree that it's 30 months? To and from Mars, thereabouts? Okay. 30 months with the same 3 other people. Well, if you weren't crazy going in, you might be crazy coming out. But we have to try it. So with that said, how much is this going to affect the cost? You know, when people say, let's go, well, before we do that, Bruno, what's the European Space Agency's feeling on this? Rick, you're talking about National Aeronautics and Space Administration with the U.S.
Yeah. The situation in ESA is the following. Until recently, we had an exploration program. Now the things have been split. Mars is more on the Science Directorate, while the rest is on the Human Spaceflight Directorate. But we work quite a lot on together with NASA and JPL in the last months to study in particular the Mars sample return. It is, of course, human mission to Mars is something which is extremely interesting, extremely exciting, and I think if you talk to the public very often, the question about Mars is there life over there, and when do we go there? So I think that's clear. It's a tremendous interest on that one. But Mars sample return, of course, would be the first step. If you think a human expedition will take a little bit longer to go there. But certainly, and I think this is where probably all together we need to make an effort. I think the Mars sample return is the first mission to prepare for the future exploration of Mars.
Okay, so Mars sample return is the first step, right? Now, I love geology. I love rocks. Every rock tells a story right there. But why do we need to do a sample return mission if, let's say, for example, what we really want to do is find life, and in order to do that, we really want to find water? Just tell us all why we have to do a sample return mission first.
I think there are several reasons for that. I believe that bringing back a sample will allow a kind of analysis which are not yet or not possible with the simple laboratory on site. Then you have capability on ground which are far more powerful and can deliver results which are actually not achievable otherwise. And it's not only in terms of geophysics property, chemistry, or so on, but if you think about exobiology, and if you want to have some traces of life, of the past life, these investigations are extremely difficult. And I think to have a sample in a laboratory here on Earth, I think it would bring a tremendous result which are just not achievable otherwise. From a technology point of view, of course, this mission is important. That is the first mission where you have a complete, in terms of architecture, you have the full element of a human mission. Before sending human, I think you will have to be able to go there and to bring back safely few rocks from the Mars surface, and probably you will have to do that several times before you can even think of going with the human exploration.
I'm right there, but we just saw a presentation about Phoenix, right? And Sergei, they couldn't get the clump of soil into the oven. But if you had been there, Sergei, you get the clump of soil into the oven, right? You'd pick it up and put it in, and that would be that.
You need a strong astronaut.
Yeah, that's probably the reason why we sooner or later have to fly humans to more complicated missions and further, because as soon as we do something simple, it can be done by a robotic mission. But as soon as we are going to do something more advanced, then we cannot do it.
And something simple. I mean, bear in mind they got a thermal evolved gas analyzer. They have atomic force microscope. They have some pretty sophisticated instruments. Yet the trouble or the loss of time has been in something. If a human were there, he or she could do easily. So that I always find that compelling. Jum, you've been nodding your head. How do you feel about this? Do you want to have a sample return before humans go?
I agree. We should have the samples first. That's we'll disclose the crews about mainly the science. However, that should relate to that how humans rely on the surface of the Mars or the other planets. And Mars is located at probably the boundary, or the border of the humans can reach, make a route to travel, from the Earth for the time being. So the first and the front and the face of that, let's say, enhancing the humans' knowledge, that should be, initiated by the robotic missions that will give us a lot of information.
Now, do you feel that we need to go to the moon first?
There might be
He's sitting right here.
Right.
He's sitting right here.
I think the moon is an immediate destination. We can go. From an astrodynamics point of view, there might be another discussion. However, that we have to convince the taxpayers and the governments. Where is this affordable, immediate destination. That's I think one reason we fight for that.
To maintain the public interest, you want to go to the moon first. Rick, do you feel that that's a justification to keep people interested?
Well, and it's much more beyond that. I mean, we're building the capabilities that will allow us to send much more mass to Mars eventually. And you talk about these labs. I mean, we would like to bring samples back from Mars because you see the size of the labs. They're fit in the bread box. And you can bring those back to Earth, and you've got buildings full of labs that can give you much more precise data on that. So being able to enable an architecture that allows us to send more mass to Mars eventually will enable all kinds of science we can't even imagine.
Okay, but what do you say to people who say, well, we can build that architecture without going to the moon?
I say we could build it, but we can't test it the way we can by doing all this trials and analogs on the lunar surface. We're putting humans at risk here. So we have to weigh the risk of how mature our technologies versus how confident are we that we can send them on this 30-month journey with no help on site other than what they leave orbit with. And in my mind, that's the lunar experiment.
Let me ask you this, as a human who has had roommates. So let's say we're going to send people to the moon for 30 months as a test. Are you going to make a deal with those astronauts, taikonauts, cosmonauts? You're going to make a deal with them that if they can hang out for 30 months on the moon, then they'll get in the queue, they'll be in line to go to Mars. Or are they, if I may, stuck with it? Do they get to get in line? Has anybody given that thought?
Well, I'm looking forward to having that discussion when we're that close that we can actually be talking about our Martian astronauts. But, I mean, we're learning a lot on the International Space Station, both in international cooperation, but also in isolation for long duration periods. And that's a key part of the journey there, the crew's interactions when they're on the surface for 18 months, the interdependence that they're going to have, and the confidence and reliability on each other to solve problems. So.
And to resolve conflicts and so on. Now, Sergei, do you think you can go to Mars without any gravity? Any artificial gravity?
It depends on how long we are going to travel.
How long were you in space at a time?
My longest mission was a little more than 10 months.
10 months.
So it's comparable with travel to Mars.
Mm-hmm.
And of course, after long duration flight, you have to recover for Earth gravity. On Mars, on Moon, gravity is lower, on one hand. On the other hand, you're going to carry a spacesuit there. So it's not...
How long did it take you to recover? How long did it take you after 10 months?
To walk normal, to run normal, it takes a couple of months, I guess, completely recover. But you can perform on the first week, actually.
The fifth week?
First.
The first week, yeah.
So maybe first couple of days is difficult, but then you can actually do whatever you want on the first day, but still to run, to jump is convenient first several weeks. So for Mars mission, probably on the route to Mars, we have to exercise, we have to get ourselves ready, our body ready to
How many hours a day did you exercise?
What we do now on ISS, and we had exactly the same experience on Mir, about 2 hours per day.
2 hours? Because I can imagine you get to Mars and you're so excited you jump out, you break your leg because your bones have atrophied. That would be a problem. Yeah. There's no emergency room on Mars, I mean, as far as I know.
So I think what was said before that we have to prepare not only scientific program like returning samples, doing chemical analysis, but I think designing mission is another big challenge, and it's another big science. We exercise this kind of activity, building station together. We do joint experiments together. So even talking about moon, I think then again we have to answer another question: what do we want to achieve? If we want just return back samples of soil, maybe it should be done by a robotic mission, and for this purpose we don't need to go to moon. But if we are going to build infrastructure to go beyond Earth orbit, beyond our area, then we have to do gradual steps.
So here, what I'm hearing implicit in there is that you think we need international cooperation to do this.
It's going to be international one way or another, because right now even technology is a little different in different countries. Countries have different advantages and capabilities. So for challenging missions like planetary missions, we will need to take the best we have on Earth.
Bruno, do you have an opinion on that?
Well, I can only concur to what has been said. I think a mission like a human mission to Mars is a global enterprise, and I think it would not be correct even that one or two agencies alone, they would make it. The effort which is required, both technology and financial and so on, is such that it has to be a global enterprise to go to Mars. I think there is no.
Jim, you're nodding? Yeah.
Yeah, no, perfectly agree with Bruno. We think we should collect every the capabilities from the world, and also that we should share the cost and investment. It's a huge investment, and we should all band together to work on.
So we go to Mars. There's still going to be nationalism, right? I think at the Tour de France, this bike race, the teams are made of people from all different countries. But when whoever wins, they play the national anthem of that person's home country. Even though the team was made of many countries. So this is another thing that's going to have to be figured out. Who gets to step on Mars first? Of course, this is a problem is a long way off, but you can take that backwards about who's going to pay for it, between now and then. So look, you guys, I want to get questions from the audience. Please, everybody, step on up. Are there any questions so far? Is somebody's waving? Renee's on it. There she goes. Here we are. Please, please.
I would like to
identify yourself. Identify yourself.
I'm Tony Gross from NASA Ames Research Center. I'd like to ask Sergei, how far do you think humans can go into the universe?
I think it depends on which way you are going to go. If you are going to go and go back, probably the Mars is the furthest place we can go with current technology. If we are going to expand our habitation area, then we can go as far as we can see. Probably in this case, probably not in a one generation time frame when you go and go back. Or maybe some generations will go to another planet system and stays there. Maybe create new civilizations there. So I think I don't see any boundaries from this point of view.
No boundaries. There you go. So is there another question, Renee? Let me ask you guys this. Let me just ask you flat out. Do you think that there was once life on Mars? Or how about this? Give me a probability. I've stumped them. This is the first time you've thought about that?
No. Well, there certainly are all the elements there. We've seen the signs of water, and we've confirmed water as a key part of life. I think the soil analysis to date has shown that it's not as toxic as we once were thinking it was. So it's very probable. I hope that as we learn more and more, we actually discover microbes, and then my question is, will there be human life on Mars? So.
Aha, aha. Well, it's at least a few years away. Anybody else? Give me a probability. 1 and 2?
Yeah, the problem, I think, is in your question. Because you ask, was there life on Mars? And I think life can be spread simultaneously in many places, and maybe some seeds of life existed on Mars, existed on Earth. On Earth, it developed. On Mars, maybe not as fast, but it doesn't mean that life, human-like life, existed and then extinct.
No. I'm looking for microbes, Marscrobes.
I think microbes spread through universe, and just some microbes survive, some of them stays in the form they are, some of them evolve to something else. So I think there is some signature of life there. And from my point of view, probability is more than 50%.
More than 50%. Now, where would you go to look for it on Mars? Are you familiar enough with Mars to pick a place?
Probably closer to the place where you have bigger spread of changing of conditions, and that's probably places close to pole. You have winter and summer when you have probably you may have some water or different chemicals in different conditions in different places. So I think probability of life to survive there is high.
Some place where the weather exercises the planet a little bit. Here we go. We have a question.
Yeah, I'm Bernard Frank from Europe. I have a question actually. It was relevant to that. How far do we need to go robotically to be sure whether there is life or not in some places on Mars before we will bring all this human and biosphere that is going completely to change the biota on Mars? So,
talking about forward contamination.
Well, so yeah, we'll find what we bring there. So how sure must we be that there is no life at all, so that we know, okay, eventually that there are places that we could go? Or when we identify microbial life, should we go there?
Bruno.
First of all, I would say that concerning forward or backward contamination, I think we have to be extremely careful. And the first thing is to avoid that. I don't think we can take any risk in that area. Concerning the presence of life and the probability of detection, that is a difficult question. I think is the condition in the past, I believe, favorable for that. I think the chance to find traces of primitive life are there. How many times we have to go, I think this is probably a question more for the scientists. Once is probably not sufficient, or the other way around. I mean, if we find the first one, then at least we have a certainty and we can plan on that and we can build the future on that one. But I think the question is that we have to do a reasonable number of samples. Still, planetary protection is the paramount importance for that. So they are, I would say, I would not put them strictly in sequence. In reality, we will have time to do many sample return before sending humans. So I think not the immediate problem for the future.
And I would add to that, certainly we have to be very careful that we take every precaution not to send contamination or to contain sample returns and handle them responsibly. But, I mean, the surface area, Mars has no ocean, so its land surface area is equivalent to Earth. So, and with you got to ask yourself, how much of that planet can you really explore before you've declared it lifeless? And
You used to have oceans, though, right?
Yes. Yes, so I mean, we will have to take, we will not have confirmation 100% at any point that we know there was no microbe or existing life there. So we just will have to mature our technologies, gain our knowledge, and then when we feel like we can safely send humans, weigh all the factors, and then launch off.
Jim, you were going to say?
Yeah, we should preserve that the surface of the moon, the Mars, but as let's say, pristine, and we shouldn't keep that the environments, until that we've seen that the discoveries or something, of that living entity. That we shouldn't clarify that what is on the surface of the Mars. That is the first thing, So until that time, that we should refrain from that forward contamination.
This just fascinates me, everybody. I mean, we're sitting here talking about this, the sort of, in a matter-of-fact fashion, discovering evidence of life on another world. I mean, if we were to do that, let's say in the next 50 years, let's say 30 years, if we were to do that, it would change the world. I mean, it would be like Copernicus or Galileo. It would be these discoveries that revolutionized humans' perspective, humans' view of our place in the universe. And it's going to be done through space exploration. And of course, if we prove that there were never any chance of life on Mars, that would be almost equally compelling, if you could somehow prove that. But with that said, you guys, going to Mars, very, very difficult business. Very difficult. What do you think the chances are of European Space Agency, NASA, JAXA, Russian Space Agency, Chinese, Indian Space Agency, developing a nuclear-driven rocket, nuclear propulsion? What are the chances? I mean, in the United States, when someone wants to build a nuclear power plant, people just, no. In France, it's all nuclear. How many people are from France? Is it true that the electricity is expensive? Is it true? Or is that a myth? It's cheap. Depends who you ask, I guess. So if we were then, in the United States, when people want to put a radiothermetric generator, a piece of plutonium, on a spacecraft, there's protests. People are very concerned that we're going to contaminate the entire world with this horribly toxic material. And so what do you think the probability of us someone building a nuclear-powered rocket to expedite our trip to Mars?
Well, I think it has to be high because that enables a nuclear-powered rocket, a nuclear thermal rocket, for instance, has twice the specific impulse or the fuel efficiency of our standard chemical rocket. So you could either get there faster or you could get there with almost half the payload that you would need to put into low Earth orbit. So it's a very enabling technology for what we would like to do to go to Mars. So I think we'll have to address all those challenges with the environmentalists and the people with concerns, but allay those concerns as we have in the past. We have launched nuclear materials before, and we just have to be very conscious and careful and convincing the public.
Remember, one fell in the ocean, and we just went out there and scooped it up, and everything was fine. I remember, yeah. So, June, you were going to say something.
I think we probably someday you should have nuclear in the power source. I think on the use of that the nuclear power must be carefully looked at, from a safety point of view. Propelled by that nuclear power, to the Mars, that might be okay. However, that returning flight, and if that return flight uses the nuclear power, we have to seriously think about if something is wrong.
Let me ask the question another way. Do we have to develop a nuclear-powered spacecraft to get to Mars?
Especially for the nuclear power, what I'm saying is not on the radioisotope thing, but on the kind of efficient technology.
No, not radioisotope. That's easy. Yeah.
No.
This would be a whole new type of propulsion, right?
Yeah, but that should be, I think, made most of, made most use of in the far, such as the outer solar system exploration for the spaceships or the spacecraft. That's on a one-way traffic, right? So that is safe.
Same thing, easy. Bruno, you were going to say something?
Well, not so sure. I mean, if we talk about the nuclear thermal propulsion, you have a technology challenge and cost and development time which are enormous. So I know there is some development took place in the past.
I think your microphone fell down. Can you radio it there? Yeah, there we go.
All right, so let's try like that. My answer was that I'm not so sure that we need to develop this kind of propulsion. And first of all, I am afraid it will not be for tomorrow. It's a technology development which is extremely challenging and extremely expensive, and it's not only the environmental condition which has to be taken into account. An intermediate step, and that's probably easier to achieve, would be nuclear electric propulsion, and that it certainly would help. But my basic question is the following. I mean, traditional propulsion is cheap and simple and heavy as well. But if you think an architecture that you have to build, in any case, a big spaceship to go to Mars, and will require probably assembly in low Earth orbit before you can do anything else. So a little bit bigger or a little bit smaller, I'm not so sure that compared to the technology challenge of nuclear propulsion, that is something which is really the decisive factor.
You have to be in low Earth orbit and do assembly up there anyway, is what you're saying, so. Maybe, let me throw this out. Maybe the future will determine it. That is to say, as robotic Mars exploration continues, it seems not unlikely to me that we will stumble on a place that seems really, really interesting. And if that happens, then we'll be in a hurry. And people probably won't see the need to develop nuclear propulsion. On the other hand, if no place interesting is found, then, or no place, let's say, no place that just makes your jaw drop, then maybe there'll be this slow development of nuclear power rockets so we can go to other more distant planets. What do you think of that? Does that let the future determine it, or do we have to plan now?
The point is the following. If you think about a new type of propulsion, either you have a system which would allow you to shorten significantly the round trip, the time for the round trip to Mars, or otherwise I think the trade-off is open. Now, to shorten the round trip to Mars, and if you go away from the minimum energy transfer that normally people consider, the amount of energy increase enormously. So I'm not sure that this is exactly what, that this is a solution to the problem.
Yeah.
Needless to say, what I said is a nuclear electrical propulsion. I'm not saying about the nuclear thermal thing. And talking about what is determined safely, it's probably depends on where that home position is. If that the spaceship is constructed at another area, that's very the risk. That has very big risk, for potentially having so radioisotope things transmitting to the ocean or atmosphere. But under the port or under this is what I presented yesterday, but the port or some other facility is constructed as such a distant place, such as the sun or some vibration point or something somewhere. That's pretty safe, and operating from that point may enable the use of the nuclear.
Be easier than low Earth orbit. Here's a question.
Hi, I'm Marie-Ève Gagné from the University of Toronto, and my question is for Mr. Krikalev. Since you've spent 10 months in space, I want to ask you if you think it's possible to actually spend more than 30 months in the same spacecraft with 2 other astronauts? Thank you.
I think it's possible because the most thing people usually worry about is crew composition, so they can handle each other for such a long period of time. I think for missions like Mars mission, motivation is going to be so high that rest, as you said, conflicts, solving conflicts would be priority of the mission. If you know that it's important, everything would be tuned to do your job the best way. So from a psychological point of view, I don't see big problems, especially if you're going to have very extended scientific missions. So if you have plenty of things to do, if you are busy all your trip, then it shouldn't be any problem from my point of view.
Well, I think the problem comes, and I say this based on science fiction, the problem comes when people disagree about how to solve a problem. And I've had, I don't know if you've had this experience, where the other person is just stupid. Yeah. And so you get in a situation where the people involved, if you have an odd number of people, they take sides. And so but this seems like it's solvable. You say that these 3 or 4 or 6 people or 8 people would be so motivated to be.
That's first. And second, the way we do it in Russian space program, in the US space program, in Europe too, we don't have stupid people in our astronaut corps.
Here's another question.
The selection process is going to be important, of course. And maybe I was just lucky to fly with very good partners, but I never felt urge to go back home from one of my missions sooner because it's difficult for me to stay with this partner. Maybe I was just lucky, but I think we can learn how to make crew going to Mars lucky too.
Yeah, here we go. It'll be fun.
Hi there, my name is Jesse Iyer from the University of Toronto, and my question is for Mr. Gilbrech. One of the most tragic things that I could possibly see happening is through our carelessness we go to another world, Mars, Europa, what have you, and through our carelessness we end up contaminating some form of primitive native life form and cause its extinction. What sort of precautions have you thought of to ensure that this doesn't happen, that we don't contaminate Mars when we go there?
Well, I mean, a lot of those precautions have already been thought of and applied. We've sent a lot of hardware to Mars already on the surface. You just saw the Phoenix lander and the Mars, the Spirit and Opportunity rovers have been there, and Pathfinder before it. So we take every precaution, working with our biology community to figure out how we best sanitize everything that we're sending to Mars so that we minimize absolutely the risk of introducing a contamination, which could potentially have a devastating effect on some life form there.
So one of the problems when we first fired up the oven, that's sort of almost literally, first heated the oven in Phoenix was, were we seeing true chlorine, or was it a result of the cleaning compound, right? That was native, or whatever expression. Sorry. And so they go to extraordinary lengths to keep them clean. But the problem is generally it's before you land, right? What level of cleanliness do you need to maintain for the spacecraft that are intermediate? But these should be a solvable problem. And as you say, you reach a level of confidence, and then you take a chance. I remember in the moon deal, two things. Everybody thought it was so sterile, they didn't stay zipped up in their biological isolation garments, the big suits. And then the other thing was people thought that they had found microbes that had survived for 2 years on the Surveyor spacecraft. But then they realized they were back contaminated. The actual contamination came from the Earth the second time. Yeah, so here's another question.
Hello, good morning. My name is David Parker. I work for the British National Space Centre, but I also have a responsibility as chair of the International Mars Exploration Working Group, which is the club of space agencies working on Mars exploration. All of that is to say that I'm a Martian and I'm enthusiastic about it. But I have 2 questions for the panel, and they're bureaucrats' questions. A reasonable guess, the cost of a Mars sample return mission is somewhere between $5 and $10 billion. a reasonable guess for cost of a human mission to Mars is between $500 and $1 trillion. So first question, which is more useful, one human mission to Mars or 100 robotic Mars sample return missions? Second question, if you add up all of the civil space budgets in the world today, it's about $25 billion a year. So on that basis, it will take 20 years of all of the civil space budgets of the year to do one human mission to Mars. And that would mean abandoning all of the exploration of all the other planets, all the astronomy missions, all of the Earth science missions, everything else that's going on in civil space. So is that the right thing to do, to spend 20 years doing a human mission? Thanks.
That is an outstanding question. That is the essence of this discussion. Gentlemen? Bruno?
I must say, bureaucrats, sometimes they have very interesting questions. And, okay, David, certainly this is one of the key questions concerning human exploration and human mission to Mars. I would say, okay, that's still far into the future. I would say let's concentrate on the first step. Let's do Mars sample return once, maybe twice or more, and then we will see how the things develop. In the meantime, we can develop also technology and help to reduce the cost. But indeed, if you look at the near future, Mars sample return is the first things to address.
No?
Yeah, this is a matter of how that the investment is balanced with the outcome or return. If there's quite a good rationale that humans' presence takes on a very requisite and the key role in the Mars and the exploration thing, that is probably a worthwhile investment. But for the time being, this I think the someday the humans will go get out of the Earth's gravity sphere, and someday that humans will go to the destination in the hundreds of years, or thousands of years. There's no doubt about that. However, for the time being, we shouldn't concentrate to the robotic the mission first. That is also but I think the most of the people can agree. And this is a question of the matter of the balance between the investment and what kind of return we can have. If the human's role is a key and essential, and in that case, that is the worthwhile investment.
Sergei?
I think we have to ask ourselves the question what we are going to do. As I said, if we are going to just return samples from Mars, it doesn't make any sense to send people there. Just to solve this problem, how to take soil from scoop, it can be done robotically, and it's proven it was done. But again, if we are going to extend our living space, there is no way to do it pure robotically. So we have to go there to live there. So I agree with you. If you start to calculate costs, cost of one simple task is cheaper for robotic missions. But as I said, if you are going to have more complex mission, if you are going to create habitable space there, then there is no way except going of human.
And I get a lot of bureaucratic questions as well as technical ones, and they're fair too, because taxpayers deserve to know why we're spending the money the way that we are. And people tend to pit science and human spaceflight against each other as if they're mutually exclusive and they don't have any mutual benefits. I view them more as a quilt instead of two handkerchiefs you have to pick. Hubble is a tremendous instrument, but it has maintained its scientific discovery in the fact that we've had astronauts go upgrade it and rebuild it, and it's been a fantastic scientific...
but it was designed for that.
It was designed for that. But again, and we are going to the moon first instead of launching off on, as he said, the mission to Mars, which would entail international cooperation because of its sheer cost and complexity. So we may learn things on the moon that say we're not ready to go to Mars for another 20 years because we learned something that is a really tough
Is it possible
problem.
to go, well, this is easy, let's go right now? Is that possible?
I would hope. That would be my dream. I would like to get footprints on Mars before my lifetime's over.
Let me before you get to the next session, let me throw this out as Vice President of Planetary Society. This idea that human spaceflight is roughly 100 times more expensive than robotic spaceflight. That's pretty good, but maybe one way we could do it is to lower the cost of human spaceflight. Maybe there's opportunities that we haven't exploited in making it just easier and safer for humans to run around in space. It could be that this perception that humans do this and robots do this is frankly left over from the Cold War, where the race, just as an outsider, I mean, I'm, of course, was born in the U.S., so my perception isn't going to be pure. But Russia had rather the Soviet Union had so many firsts with regard to lunar exploration. But the sample return, pictures, landing, soft landing on the moon was all done by the Soviet Union before NASA. But the race was to get a person there. That was the perceived thing. So it could be that there was a huge focus at the world-leading space organization at the time, NASA, and that led to this division around the world between human and robotic. It could be if we lower the cost of human exploration, this whole thing it'll become a quilt instead of swatches of cloth. Here's our next question.
Yeah. Norbert Fischer of Austrian Space Forum. I do have a question. Once we finally start the human exploration of Mars, how big do you see the risk that we stumble into an Apollo scenario? So we go there, plant the flag, do 6 missions, and then we abandon entirely. And what would you do to mitigate this threat?
Well, I think
Bruno, that's a great expression. Sergei, please.
I think to mitigate the risk, we have to educate the general public. I think one of the problems we have now with space exploration in general, average public interest is going down, or at least for several previous years, maybe a couple of decades, it was going down, and as a result, we don't have infrastructure built in such a way that we can do this human exploration cheaper. I would like to return maybe a little bit back to previous question about cost of the missions. Again, if you compare complex human type exploration with a simple robotic mission, of course, a robotic mission is cheaper. But if you, for example, I think Hubble is a good example. If you would try to build an instrument, automated instrument, that do what Hubble did without any human intervention, then you will have to build it, I don't know, several times heavier. You will have to have all spares on board. Probably the spares would fail anyway. So you will have instruments that perform the same function what Hubble did is going to be much more expensive.
You have to be self-repairing.
Yeah.
Have to detect the failure and repair it. Yeah.
So there is no easy way to compare things. And again, if you return back to how people start flying airplanes, what was efficiency of first Wright brothers flight? What was cost relative to return? Who knows? But if they didn't do this more than 100 years ago, we probably will still stay on the ground. If we would try to do it completely robotic mission, it probably will slow down the development of aviation for decades. So I think it should be a reasonable balance of manned and unmanned activity. And I agree with you that infrastructure, or building reasonable infrastructure, would reduce cost of the mission significantly.
June?
I think on here question that, well, it's a question, not a question, but a kind of like comments, we have not enough and mature technology, for the humans must flight. I think that is true, and we should pursue that technology development, through that the repetition of the robotic missions policy to, enhance our, the credibility. That's another solution, and it's a gradual step, It's not a quick, immediate and quick start for the humans, human Mars mission.
So it's part of the process to have robots. Yeah.
But if I may comment,
Please, yes, Bruno.
If I may comment on that, and both on this aspect of having one at a time mission, and also on the global cost, on the total cost, which is obviously extremely high. I would like to see maybe the positive aspect of that. A mission like a human mission to Mars, it has to be a global enterprise. It cannot be afforded by few people. And I think it should really be planet Earth going to Mars. And then I think it may become affordable. And the positive side of that, it will force many people to cooperate, which I think is not a bad thing.
One other element, I think, as far as whether we go there and put flags and footprints and then the program goes away like Apollo, I mean, that was really a race, and it was designed to get there as quickly as we could with the technology we had. That's why we're looking more as the established outpost, like instead of racing to the South Pole, we're trying to put that research facility there for the long haul. And I think if you take that approach with the moon, and that's your outpost, that's your approach going into Mars, you stand to survive that kind of political unrest.
Long-term, longer-term thinking, right. Here, one more question. Next question, Madam.
Yeah, thank you. My name is Friedhelm Klaasen from the German Space Agency. I would like to revisit David Parker's question in a different way. How much moon can we get for the money we have available, and how much Mars can we get for the money we have available? I guess we can do science on Mars and start real exploration on Moon. First robotic, the next step, human spaceflight to Moon. That must be a sequence depending on the available money, because we are not allowed to print money. We should be realistic.
So let me ask you, before you sit down, do you have a fraction or a percentage that you'd recommend? Moon, Mars, 10%, 30%, 50%?
No, I don't have that percentage. But we should concentrate for scientific aspects, of course, for Mars, like we are concentrating on other bodies. But if you want to do real exploration, that means preparing human space flight, not only falling around the Earth like ISS does, really space flight, then we have to prepare that on the Moon and not on the Mars, just for cost reasons.
So that's, how do you guys, June?
First of all, we should not sacrifice any scientific return on robotic missions. That's the first and the important thing. And I think each nation, each agency should have some its own policy, and it wants to retain that autonomy. And even that the scientific mission is a kind of the policy, of the agency and the governments, to prosperous and to have a prosperous future for that agency or a nation, country. And having that the humans flight is probably in the cost pretty much 100 times as much as money as the robotic missions. That's it's a kind of an incentive on to that I have that the science and technology they deployed and developed and so much. It's a kind of also a policy. If that the one single man's humans mission extracts hundreds of the scientific outcome or technology developments, that's the leads to the prosperous future of that nation. So that the balance is still that the matter of the balance between the investment and the outcome. So we should carefully look at how much cost we should invest. And once again, that the humans flight for the Mars is not an immediate step we should take. We should wait for some much more detailed discussion, and also we should look at how that the technology is mature for that purpose.
You want a more detailed discussion? I thought the five of us were going to solve this problem this morning. Wow, who knew? Rick, did you have something to say? We have one more question.
I was just going to say that each agency, of course, we have our own budget limitations that we have to balance our own priorities, but part of cooperation is that we can look at how we complement those budgets to gain maximum scientific return, and also strategize on how we can advance the human spaceflight exploration to the most extent. We have a presidential mandate that we go to the moon by 2020, so we are on that path, but we're trying to engage the international community so we can strike that balance and maximize the return and not have one at the sacrifice of the other.
Together. Yes, Renee, here we go.
Stephen Day with International Ventures. I've got a social question for you. Assuming that the purpose of life is to reproduce, have any astronauts had sex in space? And the second follow-on question is, when can we expect the first extraterrestrial birth?
Now, my understanding is NASA has an official policy on this. Rick, can you enunciate it for us?
Well, to my knowledge, there's no. That's an interesting question.
No, I'll fill you in. No pun intended. That NASA, a husband and wife astronauts flew almost 10 years ago, and they have no comment. But I hope they have a comment someday. My goodness. You know, there's science fiction books have been written about how great it would be. When do you think there'll be a birth in space or on another world? I think it's a long way off. I mean, I'm interested in it. I mean, don't get me wrong, but that's another thing.
I think the birth outside the Earth can happen when we are going to be comfortable outside. Still, all these exploration missions, still exploration, it's still going to something dangerous and unknown. So to put someone else who are not making decision to be part of this adventure is not feasible right now. As soon as we're going to be comfortable living outside the Earth, then it may happen.
Well, this is a social question. I don't want to get too far afield here. But, well, it's going to end my career. I can't talk about it. But I'm sure you could find people who would make this a goal. This would be something on the checklist, on the cuff of the gauntlet. One more thing to get done. I'm sure you could find volunteers for that mission. Whether that's significant or valuable is a whole nother. So is there, one last question? Is this what we're going to do? Hold on, Bernard. One last, I guess we have time for a couple more. Let's have this one and one more.
Hello, my name is Alexander Dokhtyar. I'm from Ukraine, Kyiv Taras Shevchenko National University. Gentlemen, how do you think, what's the most biggest problem in this task? Technology, money, or just simple we still can work together very good, because this is international task. Thank you.
Well, at least from my perspective, technology is not what keeps me up at night. We have our challenges, but we've chosen a very evolved architecture instead of some of the more revolutionary technology attempts of the past. It's really stability, a commitment, and purpose from our legislature, our leadership, that allows us to continue the path we're on. That's to me the biggest challenge that I see in the face, is having a long-term vision and being allowed to execute it and not being revectored every 3 or 4 years with the whims of the political system.
So you think that the hardest thing is the United States rather, would not stay on course. It would change the vision.
Yeah, and we currently have good bipartisan support, so I'm very hopeful and confident going forward, but that is a risk to us, is being able to stay the course over the long haul, because these are long strategic missions that we have to design, and a lot of the hardware takes a lot of years to mature, and you got to be allowed to stay on a steady course.
Indeed, I think when we talk about undertaking like a human mission to Mars, I think it needs a long preparation, I think it long maturation, and as I said before, it has to be a global undertaking, and that means that there is a consensus, a very large consensus to go that way. Otherwise, it will just not work. And for the rest, I certainly would agree with our friend from DLR. If you look at the immediate future in the next 10, 20 years, I think indeed is human exploration to the moon, robotic to Mars, but human mission to Mars is in a different time scale and also in a different dimension. And I think this is still to be built. And it will take certainly quite some time before we come there.
But would you agree we need to just keep going?
We need to keep going, because it will take a lot of time to create a consensus, to create the environment for such a global enterprise.
Outstanding. Okay, last question. Bernard.
Yeah, actually I have a challenge for you because, okay, humans to Mars looks very remote, but we have the challenge of life beyond Earth's orbit. And for instance, we could have a challenge of bringing Earth's life, even microbial, animal, plants, to the moon, already making use of robotic mission to learn how to support life. And then we have the challenge, okay, having a human international base that is also together with a number of the other species that we could sustain. Another challenge is having kind of sustainable biosphere there. So I believe that it could be done in a much lower cost approach than going directly with humans to Mars. But how could you prepare that? Could you think of some robotic precursor that can bring and sustain some form of life, grow a flower on the moon, use resources, and learn how to live on another planet?
Well, I mean, that's what we're doing. We're going back for 6-month outpost stays on the moon, and that could be continuous. I mean, those could be multiple 6-month excursions.
You could have a greenhouse and grow plants.
Yeah, but it's...
Are we all in?
I think to use robots to understand how to live is a strange statement. To learn how to live, we have to live there sooner or later. So.
To learn how to live there, we have to go live there. That's fantastic. Well, thank you all very much. Thanks for sticking around. I hope that this Congress has affected all of us, giving us a lot to think about with regard to humans' plans in other worlds. And I'd like to thank everyone on the panel for taking the time this morning with your really 3 or 4 times I had a whole new insight. I hope all of you had a few insights today. And let us go forward and, dare I say it, change the world. Thank you all very much. Good morning.